In this experiment, I investigated Newton's second law. Newton's second law states that the final velocity equals the initial velocity plus the net force divided by mass times time. I chose to model constant motion and also observe a real-world example of constant motion. I chose to use a basketball. I rolled this basketball and captured its motion on camera. I then imported the video into a program called Tracker. Tracker helped me take data on the position of the ball over time. This is the data from my observations. Using the same parameters involved in the real-world example, the time of the test, the mass of the basketball, the initial position, diameter of the basketball, I modeled the basketball's motion in Python. As you can see, the observed motion and the modeled motion is very similar. In my model, I made certain assumptions to make the model as close to the same as observed. I assumed there was no net force, and the observed and the ideal model most likely differ due to my human error. In Tracker, I may have mismarked points leading to a faster position than the ideal. Realistically, my observed points should start out as the same as the ideal, and then slowly drop off as friction has its way with the ball. What if? In Tracker, I chose to make my axes positive. Had I chosen to make my axes negative, the data points would simply be negative and the velocity would have been in the negative direction. This does not matter much. What does it mean? Yes, it is possible to say what pushes and pulls there are in this railroad experiment, and I could theoretically model these forces. I can measure the force at which I rolled the ball, the friction coefficient of the floor and the friction force, wind resistance, tilt of the building, and so forth. Having all this data, I could have modeled all of this in Python.